Chapter 4, Lesson 3 of Pre-Calculus, and again we want to tie something that we've learned before into what we're learning about these coterminal angles, and that is the special triangles we looked at, the 45-45 90s and the 30-60 90s. And the connection can be made with these coterminal angles and what we were talking about in the last video, where if we have a point in the coordinate plane and we draw a line through that point and we draw a reference triangle, then this theta, the sine, this cosine, the tangent, all of these trigonometric functions for this angle from here to here are going to have the exact same value as any angle that's coterminal with it. So this theta, if we took theta and we added 360 to it, and came all the way back around, the sine, cosine, tangent, the six trigonometric function values would be exactly the same as this theta if I were to calculate the six trigonometric functions for this angle here. And then if I went around again, they're the same. And if I went again, they're the same. Or if I went around again, they're the same. Or if I went the negative direction, they're the same. Or the negative direction, they're the same. And you just keep going round and round and round. And as long as you stop here, the six trigonometric ratios are going to have the exact same value as this ratio as this angle from here to here. So knowing that, if we are given an angle whose coterminal with one of our special right triangles, we can calculate the six trigonometric ratios using those special triangle ratios. So let's say I asked you to give me these six trigonometric function ratios, so all of the trig ratios, for an angle that's 315 degrees. Well, if I was to draw the 315 degree angle in my coordinate grid using, this is my initial side, and then rotating 315 degrees, starting here, this would be 180, this would be 270, then some more in here. So this would be my 315 degree angle. Now, if I determined what this angle was and I drew a reference triangle, I could calculate those triangles or those ratios. Now, if I take 360 minus 315, it turns out that this angle right inside here is a 45 degree angle. And because it's a 45 degree angle, this is a 45-45 90 triangle. Therefore, if I make this 1 and this -1, because the y value is negative, then I know this is radical 2. I can write all of my trig ratios based upon what I know about the 45-45 90. So the sine of this 315 degree angle is going to be 1 over square root of 2. The cosine of this 315 degree angle is 1 over the square root of 2. And the tangent of this 315 degree angle is the -1 over 1, which is -1. And then again, the reciprocal function, the cosecant of this 315 degree angle is the reciprocal. The secant of this 315 degree angle is the reciprocal. And my Starbucks is here. And the cotangent of this, I'm getting all excited about my Starbucks. My cotangent, I'll get it, stop right there, 315 degree angle is -1, or 1 over -1, which would be -1. So you can see, if this angle relates to one of my special right triangles, I can plot it in my coordinate grid, draw my reference triangle, use the sides that I know, and write my ratios very quickly. So we can connect what we know about 30-60 90s into these coterminal angles that we're talking about, because any angle that has this as its terminal side, the ratios are going to be the same no matter what the measure of the angle is. So you can see that we can do this with any angle that's coterminal with any of our special triangles, and we'll be able to calculate the six trigonometric functions or a single trigonometric function. In fact, let's do one example of that, looking at an angle in radian measure, and then we'll look at quadrantal angles. So let's say we were asked to determine the sine of a 5 pi over 4 angle. Okay, so again, we're going to use the coordinate grid, and 5 pi over 4, you remember 4 tells me that it's a 45 degree angle. And then the 5 in the numerator is how many 45-degree angles we have. There's 5 of them. So I have 5 45-degree angles. And so if I start here at the positive x-axis, I have 45 would be 1, 90 degrees is 2, and then 3, 4, and then so one more would put me right about here. So this angle here is 5 pi over 4. Now I want to draw my reference triangle, so I'm going to draw my angle or my perpendicular side to the x-axis. So because these are multiples of 45, I know that this angle inside this triangle is a 45, or it's a 45-degree angle. So therefore, let me get rid of this so it's not confusing to us here. So then I know I can use my knowledge of special triangles. I know that the sides are both 1. So this is left, so this is negative, and this is negative in quadrant 3. And so I know that this is the square root of 2. So again, the sine of 5 pi over 4 then is again the opposite side, which is negative 1 over the square root of 2. Now, we could do this a little bit quicker if we remember that what the sine ratio is, and then all we have to do is know what quadrant we're in, and then we can do what we learned, or use what we learned about the relationship between the y values and the sine and the x values and the cosine, meaning the y value in this quadrant is negative, so the sine is going to be negative, so I knew that. And then if I remember what the ratio or what the sine ratio of a 45, 45, 90 is, I can get this ratio rather quickly. Okay, but irregardless, we can always draw our reference triangle in order to determine the 6 trigonometric ratios or any singular trigonometric ratio that I wanted. Let's take a look at one more concept in this video, and that is the concept of what we call quadrantal angles. What happens with these? So let's take a look at those. Quadrantal angles. A quadrantal angle is any angle that in radian measure has a denominator of 2. And you remember when we talked about these that any radian measure with a denominator of 2 is a multiple of 90. And the problem with these quadrantal angles is that when we take a terminal side and we begin here at the initial and we rotate it 90 degrees, the terminal side is going to fall upon one of the axes. So for this example, pi over 2, the terminal side is this y-axis, this positive y-axis. And the problem is, if we take a point and we try to draw our reference triangle, we're going to draw a line perpendicular to the x-axis. That's going to be a line right on top of the x-axis. Well, that's no triangle at all. And if we happen to be doing like the angle pi, when we're on the negative x-axis, you can't draw a triangle perpendicular to the x-axis because you're already there. So there is no reference triangle that we can draw, so how are we going to determine these trig ratios? Well, it's actually not that difficult. You remember that any point along the terminal side, when you draw your reference triangle, that all of the angles or all of the trig ratios for any point on that terminal side are going to be the same, because the angle doesn't change and the length of the side doesn't affect the value of the trigonometric ratio. So no matter where we pick a point, our R value doesn't matter because the ratio is always going to be the same. So all we have to do here is to pick an R value that's comfortable for us. So let's pick the easiest R value. Let's make an R value of 1. So let's make the length of this terminal side 1. So that means the coordinate of this point is going to be 0, 1. And my R value is 1 because that's the length of my terminal side. So once I have that, I can go ahead and do my trigonometric ratio. So the sine value, and again, is related to what? The y value. So the sine value is the y value, which is here 1, over the R value of 1, so 1 over 1. And then the reciprocal function, the cosecant of pi over 2, would simply be r over y, or 1 over 1, which is 1. Now, when we do the cosine, you remember that cosine is related to the x value. So I take the x value, 0 over r, which is 1. 0 over 1 is 0. And if we do the reciprocal function, which is the secant, Now here's where you got to be careful. The secant is the reciprocal of this. So, or r over x. So if I take r over the x value 0, that gives me a denominator of 0, which is undefined. So actually the secant function for this is undefined. Okay? Or if you just took the reciprocal of this, 1 over 0, that would produce an undefined value. Then if you take the tangent of pi over 2, which you remember was y over x, well here y is 1 over x, which is 0. Again, it's undefined because we have a 0 in the denominator. And then the cotangent function is the reciprocal of that, so that'd be x over y, so that'd be 0 over 1, which is 0. So with these quadrantal angles, you are going to end up with a couple of these trig functions which are undefined. So something to take note of is that if you ever have an undefined trig value, you know right away that you're talking about a quadrantal angles, because quadrantal angles are the only ones that will produce these undefined values. So the different quadrantal angles that you'll need to remember, and just remember we are always going to take a length of 1 for our terminal side. So if you're talking about this quadrantal angle here, and this is a length of 1, this is going to be -1, 0. So again, you have your x, your y value, and then your r is a 1 because the length of this is 1. If you're talking about this angle here, then again, this length is 1, so this coordinate is 0, -1. And again, you have an r value of 1. That's the length of the terminal side. And then if you're on this particular axis, then the length of this is 1, this coordinate is 1, 0. And again, you have an r value of 1 because the length of the terminal side is 1. So if you remember those values, then that's going to make determining the trig functions of these quadrantal angles rather easy. So there's one other type of problem we want to look at, and it kind of ties together everything that we've learned in this video. We know that the sine of theta is, let's say, 3 over 7. And the tangent of this angle, whatever it is, we don't know what it is yet, but we say that we know that it's less than 0, meaning it's negative. So if we know those two pieces of information, I would like you to give me the cosine of this angle and also give me the cotangent of this angle, whatever it is. All right? So how are we going to do this? So what we're going to have to do is to tie together everything that we've learned so far. The first thing that we need to know is, where is this angle? In other words, which quadrant does it lie in? And I'm going to use these two pieces of information to determine that. Because I see that the sine has a positive value, I know it's either in quadrant 1 or quadrant 2, because the y values and consequently the sine values are positive in both quadrants. So which quadrant am I in, this one or this one? The second piece of information will narrow that down to the correct one, because it tells me that the tangent of the same angle has to be negative, which means the x value has to be positive and the y value negative, or vice versa. One of the two values has to be negative. Well, that takes place in quadrant 2, where we have a negative x value and a positive y value. So I know that the angle we're talking about then is in quadrant 2, so I'm going to draw my reference triangle in quadrant 2. And so this is the theta that we're talking about. This angle, whatever it is, has a positive sine value and it has a negative tangent value. Now I can use my knowledge of the ratio sides of the sine to label my triangle. I know that the sine is the opposite side, 3, over the hypotenuse side, 7. And now I can use the Pythagorean theorem to figure out x. And this is going to be a negative value because I went left. Okay, so just keep that in mind. So I can apply the Pythagorean theorem. X squared plus 3 squared is 7 squared, and solve this. So x is going to be the square root of 49 minus 9, or the square root of 40. So I know that this is the square root of 40, and I know that it's negative. Now you could simplify that radical at the end if you want, or you just leave it like this for now. In most cases we might ask you to do a decimal at the end, so there wouldn't be any point in determining it now. But it's okay to leave it like that to write the original ratio. So now that I have this side, I can go ahead and write my ratio. Now, just a point of, just kind of point this out. So what's the coordinate of this point? The coordinate of this point is negative square root of 40. That's the x value. And the y value is 3. So I can now write the ratio. So the cosine of this angle is negative adjacent side over hypotenuse. And I should have written this down a little bit longer, so let's just go here. The cotangent is not the opposite over adjacent, but adjacent over opposite, 3. So you can tell my tangent is negative, which I said I should have. So based upon just these two pieces of information, that will determine what quadrant I draw my reference triangle in. I then use what I know about the ratios to label the triangle. I use the Pythagorean theorem to determine the missing side, and then I can write the rest of my ratios if it asks me for all of them or just the particular ones that it asks me. Okay, so that will wrap up this video. I will do an example video where I'll do a number of examples where we ask you to do problems like this. So you can check that out if you're not sure, or just watch this video over again, just this sample problem, so you get an idea of what we're doing. And we'll wrap this video up with that.